We've seen how electrons can build up in an object, from a balloon to a thunderhead, to create a charge of static electricity. We've also seen how the charged electrons can jump in a single spark to another object. It can be fun, silly, or downright scary, but it isn't very useful. That single spark won't run our electric lights, or toasters, or TV sets. To make electricity work for us, we need more than just a spark. We need a steady flow of electrons. One way to do this is with a battery. Every battery has two connections. They're called terminals. One terminal always has a negative charge, and the other always has a positive charge. Battery terminals don't get their charges by being rubbed together. They get their charges from a chemical reaction inside the battery. We know from our experience with static electricity that if we brought these two terminals together, the charge at the negative terminal would jump to the positive one. Of course, we can't actually bring the two terminals together, so we connect them with a wire. This is how we make electricity work for us. We'll attach one end of the wire to the negative terminal and the other end to this light bulb. Then we'll attach another wire to the bulb and to the positive terminal. There. Moving current electricity follows a path from negative to positive, lighting the bulb along the way. Because of the chemicals in the battery, there is a continuous supply of electrons at the negative terminal, and so the current keeps flowing. Of course, we couldn't do this without a wire. The wire carries or conducts electricity. Earlier, we found that all sorts of materials will hold a static electrical charge. Now let's see if those materials will allow current electricity to flow through them as the wire does.
Oh, if electricity will pass through one of these things, the bulb will light up. It doesn't go through cloth or the cone, but it does go through the fork. Not the bread, but electricity will go through the aluminum. I know what this is called. Things that electricity does pass through are called conductors. Things that it can't pass through are called insulators.
Right. Rubber and plastic are insulators. That's why electric wires are covered in rubber or plastic to keep the electricity from flowing through your body. A small battery is relatively safe, but the current at a wall outlet is equal to many, many batteries and is very dangerous. You should never experiment with anything attached to a household current. Now let's take another look at our battery and light bulb. See how the current follows a circular path? It starts at the negative terminal of the battery, flows through the wire, through the bulb, then back to the positive terminal. This circle is called a complete circuit. If we break it anywhere along its path, the flow of electricity stops and the light goes out.
That's how you turn things on and off.
Right, but we don't usually unhook the wire. We use a switch to break or connect the circuit, and they all work like this. There's a switch in this flashlight. The current electricity starts at the negative pole of the battery, flows through the metal spring and along a metal strip up the side of the flashlight. But here we have a break in the circuit until we move the flashlight switch. That pushes another strip of metal into contact with the first one. Then the electricity can flow through the bulb.
Back to the positive pole of the battery.
Right. We have a complete circuit.